Today our session expert is Professor Yaduvir Singh. Professor Singh obtained his Bachelor of Science and Engineering in Electrical Engineering degree from the Dalbagh Educational Institute, Deemed University, Agra in the year of 1991. Master of Engineering in Control and Instrumentations from Motilal Nehru Regional Engineering College. Now it is known as Motilal Nehru National Institute of Technology, Prayagraj, University of Allahabad, Allahabad in the year of 1993, and Doctor of Philosophy in Industrial Electronics from Thapar University, Thapar Institute of Engineering and the Technology, Patiala in the year of 2004. Dr. Singh completed his PhD under the supervision of Dr. P.S. Bhimra, who is an iconic figure, nationally and internationally acclaimed electrical engineer and an academician of par excellence. Dr. Singh, as a teaching faculty, has served any regional Institute of Science and Technology, NERIST, Itanagar, GB Pant Engineering College, GBPEC, Pauri, Garhwal, Harcourt, Malta Technological Institute, Kanpur, HBTI Kanpur from 1995 to 2000. Kanpur and Thapar Institute of Engineering and Technology, Patiala till end of year 2011. Dr. Singh had been director of Noida Institute of Engineering and Technology, Greater Noida, and executive director of NIT Business School, Greater Noida from January 2012 till March 2013. Before joining HBTI or HBTU Kanpur once again as a professor and head of department, then World Bank TechCube coordinator and dean. With more than 163 research publications in various conferences and journal of repute, he possesses nearly 32 years of teaching and research experiences at UG, PG and PhD level of engineering and technology. He has guided more than 90 projects, 65 master level thesis, dissertations, MS projects and 12 PhDs. Dr. Singh has authored 22 best-selling technical and non-technical books in the areas of electrical, electronics, subcomputing, life engineering, and the spirituality. He is considered to be an encyclopedic writer in these areas. He can be easily traced on e-commerce platforms like Amazon and Flipkart through all his books. He is a holder of 2 patents. Includes Dr. Singh's research interests are the areas of electrical and electronic systems, intelligent systems design, subcomputing, automations and advanced control systems, data science, machine learning, artificial intelligence systems, industrial electronics, robotics, system modeling and identifications, graph theory, design of instrumentational systems, Internet of Things, etc. on the technical side, and exploring the life and the spirituality as the engineering of the life. Thank you, Professor Singh, to accept our invitations and for attending our the sessions. Okay, thank you, sir. So, okay, sir, this is from my end. Please start your presentation, sir.
Okay. Thank you, Dr. Good morning once again to you and to everybody who is listening to me on the other end. Dear friends, today discussing about data science techniques and how they can be they are being linked to the global sustainability. We as engineers, we have to create solutions to the various problems, and the goal is to reach sustainable solutions for the various problems. Dr. Arnab, am I audible and also my slides are visible to all? Just confirm it once.
Yes, sir, you are properly audible and your slide also visible to us.
Okay. Very nice. Thank you. So, dear friends, moving on to formally with my talk of the today, just for motivation of myself and maybe that my other friends will also like it who are on the other side. He's a monk, God Gopal Das from ISKCON. basically electrical engineer, graduate of College of Engineering, Pune. He has said that self-discipline is about taking charge of your mind and directing it in the best interest of yourself. So, right. So let's get motivated in our own styles by this quotation, this statement. Dear friends, since this STC, this faculty development program is all about sustainable solutions, sustainable development. So it's very important to just revisit what are the UN Sustainable Development Goals, which have been inked at the international level. We very popularly we call them as SDGs, Sustainable Development Goals. The United Nations, right, they have set forth various goals for various purposes to end poverty, to protect the planet, and to ensure prosperity for all who are living over here as a part of a new sustainable development agenda. Therefore, it's once we talk about sustainable development goals, there are various problems for which sustainable solutions are to be offered, the problems of the mankind, the problems of other organisms, and the problems which have been created by the human developments on this planet, all have to be addressed and they are to be solved. Right. There is a need for more comprehensive understanding of high volume data, how to process, handle, and interpret it. Because most of the problems which we see, right, which lead to the right various aspects, whether it is poverty or energy. So the first and foremost, the very important thing is that to define the problem. And once we define the problem, right, we start digging the problem, the various data and the information related to the problem. So what we find that the data which happens to be after the data has been dug, it's a very high volume data and very might be heterogeneous also. So therefore it requires a very careful data processing, data handling. And after that, the one of the most onerous job, one of the most important job is to interpret the data. At the UN, at the United Nations, right on their agenda, the various issues which need to be addressed, which have been identified globally, are poverty, food, clothing, shelter, theft, energy, environment, ecosystem, pollution, terrorism, wealth division, digital divide, one of the new issue, cyber security, open defecation, etc. So, these are some of the issues which have been identified globally, not only nationally, as the sustainable development goals, and the various problems therein need to be addressed very carefully. So the scarcity of the food is one of the major issue which always poses a threat to the existence of all on the planet. These are just few introductory slides, then I shall be moving on to the technical aspects leading to right food grain production, sustainable agriculture, sustainable farming is also one of the big area that has been identified at the United Nations level for sustainable development. Clean and proper habitation. So we might have seen such kind of scenes all around whenever we travel or might be wherever we are living. Shanties, very poorly, poorly created environment with very poor hygiene and in fact no sanitation. Not only it's a threat to the human life, but also to the others. Garbage, waste disposal. Waste disposal is also one of the very bigger area. In fact, with the coming of now electrical vehicles are coming up. So how to handle the battery waste would be a problem in the future, which we engineers have to address. So reuse, recycle, and all these issues will be there for that. technical solutions are required. And the normal waste, the solid waste which we see otherwise, solid waste management handling is also one of the very bigger area. In fact, we electrical engineers, right, and the other engineers from other domains, collectively we have tried to generate electrical energy from the garbage, but somehow it's not a very right profitable option, because the amount of the garbage which is there that needs to be processed and the amount of the electrical energy which is being generated is very less in the proportions. So it's not a very profitable or a viable solution, but yet the developments need to be done in these areas. The waste which is the litter, the waste which is lying on the soil, in the water, again a very common sight which we all see. One of the very biggest area, right, which we electrical engineers and the engineers from other domains, they might have seen, is power theft. Right. So that also creates a lot of not only the issue of power quality, but also there are other derivative losses, like loss of the revenue on the non-technical side and power quality on the technical side. So power theft is also one of the very bigger problem that needs to be addressed technically. Of course, nowadays there are smart metering devices and smart distribution systems have been deployed, but still there is need to further work on it. Terrorism is also one of the right problem being identified internationally, for which the solutions need to be offered. Technical solutions need to be created, open defecation, etc. Of course, right on the one side, where we have so many problems, on the other side, the engineers, the scientists, professors, teachers, and other, we are working day and night to right help the mankind in exploring this planet and the universe further. And the technical solutions are being created. ISRO is one our organization which has contributed a lot, right, in the form of Chandrayaan and now Suryan L1. Yeah, we do have a very strong side, that is the side which is otherwise not visible. The things related to the energy, not to the matter. The religion and the spirituality had always been in the core of our country. So it's not that science and engineering, right, or the knowledge, what we talk about, works in the isolation. Rather, it's all integrated. It is intertwined, right? So science, religion, spirituality, everything, right? They go together, and they must go together. Then only we would be able to satisfy and meet the goals of sustainable development. So, okay. Now, formally coming on to the contents which I shall be discussing, sharing and discussing in my today's talk: data science, AI, and some of the architecture, some of the solutions over there. Okay. Hello. Yeah. So the table of contents, right, the things which I shall be discussing, and then their applications I shall be discussing, right, will be related to the fuzzy logic, neural networks, genetic algorithms, IoT, Internet of things, and applications. Right, just 1 minute. Just 1 minute. Dear friends, right, we all know that AI is the branch of computer science. In fact, the engineers from a very, and we are talking about the automation of the intelligent behavior. This is one of the definitions given by Luger and Stubblefield in 1993 about AI. And some of the well-known, very hackneyed technologies which are used in AI, they are fuzzy logic, neural network, genetical algorithms, and many, many more are there. So people are using these things in their own style, depending upon their level of understanding and how they can be integrated, they can be gelled with the various problems. They can be converted into the solutions for the various problems. Dear friends, right, of course, for logic we have used in various applications. It's not something which is very new. In fact, for the past more than 3 decades, we all had been using many of our BTech projects. They have been done using fuzzy logic. So one of the fantastic thing of fuzzy logic, right, is that so many membership values, right? Fuzzy logic is the approach that is based on degree of truth rather than true or false. We all know very well. So instead of 0 and 1 alone, there are many other infinite number of memberships can be created. And this idea of the fuzziness, in fact, many of the situations, what we see, they cannot be discretely categorized into two categories. Right, well addressed those. So somehow the fuzzy logic got an edge over there, and this was being implemented. Some of the application areas of fuzzy logic, right, which already have been developed, they are for right. I have written some of the application areas, products, right, kiln control, right. There are commercial products, right. They used fuzzy logic for mixing the cement, microwave ovens, right. Already they are available in the market commercially. Mitsubishi Chemicals, they had done work over it, and they had set the right power and the cooking strategy by using fuzzy logic. Palm top computers, right, having some partial control. The logic is being written in fuzzy logic. So the companies Hitachi, Sharp, Toshiba, they had used fuzzy logic for handwriting, handwritten character recognition, etc. Plasma etching a product, right? There also fuzzy logic was used for setting the etching time and the strategy how to etch the plasma. This was one of the product which was being developed by Mitsubishi Electric. Dear friends, right, probably many of us might have taught, right, or maybe that we have studied at some level in our engineering, or maybe in masters, or maybe in PhD. So the four very basic things which need to be done whenever we are working on fuzzy logic is, right, the very first thing is what we call as fuzzification. So fuzzification is actually converting the analog number into range in the range 0 to 1. So this analog number, the fuzzification, what we say, right, dear friends, when we talk about fuzzy logic application for some industrial purpose, right, the analog input that will come from the sensors, right, right, after that signal being suitably conditioned has to be converted into some suitable value in the range 0 to 1, including 0 to 1, and that is called fuzzification. After that, so defuzzification is just the reverse of that. The rate, the the signal which is already right in the output of fuzzy inference, which is having some membership value in the range 0 to 1, including 0 to 1, is being converted back into the analog value, and that is exactly called defuzzification. For example, right, when we talk about flow rate control or temperature control, the data that is being sensed, right, the thermistors, the thermostats, right, other temperature measurement devices which are being deployed, they pick the analog data, right, right, whatever is the temperature, 4 degree, 14 degree, whatever it is, and then it is being A to converters. It is being converted, and then we convert that into the code 0 to 1. When it is being given to a fuzzy processor, the fuzzy processor does fuzzy inferencing. So in the very center, fuzzy inference block is being shown. This fuzzy inference block is for the purpose of processing the input data that comes to it, and then creating the output data. Fuzzy inferencing requires certain fuzzy rules, what we call as fuzzy rule base. So this fuzzy rule base is being created by the expert in that particular application area. For example, if you wish to create a fuzzy logic based medical diagnosis system, so for that, the fuzzy rule base, the various rules, the various prescriptions for the various ailments, for the various diseases are to be created in the form of the rules with the help of a doctor, who is already there. So the fuzzy rule base will be given by the expert, expert in that particular area. If we wish to create a stock market prediction system using fuzzy logic, so again, the various rules related to the stock market and the various and the various skills, the knowledge has to be put forth, has to be created by the expert who is in the stock market area. So like that. So depending upon the application area where we wish to create fuzzy logic, where we want to implement fuzzy logic, the expert has to be consulted, and his or her views are to be transcribed in the form of the fuzzy rule base. So these four are the main components of creating a fuzzy logic model for a solution for a problem: fuzzification, fuzzy inference, defuzzification, And this fuzzy inference will work with certain fuzzy rules which are stored in a certain storage in a certain space in the memory called fuzzy rule base. Artificial neural networks are also used in a very big way. In fact, fuzzy logic applications. Fuzzy logic, of course, being a very robust technique, is not very much adaptive, is not very much fault tolerant. So some of the limitations, some of the weaknesses of fuzzy logic, they have been well addressed by artificial neural networks. So artificial neural networks, they are the piece of computing systems which have been designed to simulate the human brain. In fact, ANNs, we call them as ANNs. ANNs, they have been created on the basis of biological neural network. That is the human brain. So inside the human brain, what the medicine says that, hello, that we have, yeah, hello. So, what the medicine says that inside the human brain there are there are many trillions of the, in fact 10 to the power 11, that much neurons remain, and they all do some computing. So there is a distributed computing, there is a distributed processing that happens inside the human brain, and the same working of the human brain has been taken as an inspiration to create artificial neural networks. And artificial neural networks, again, since they are being put for various problems, to solve the problems of day-to-day engineering, non-engineering problems, data processing, So ANNs are being created by taking the by mimicking the behavior of human brain, biological neural network. ANNs, it is the foundation of AI and solves the problems which otherwise were very difficult to solve. This ANN has proven to be one such alternative to artificial left side column, process modeling and control, machine diagnostics, portfolio management, target recognition. These are some of the application areas: medical diagnosis, credit rating, targeted marketing, voice recognition, financial forecasting, intelligent searching, fraud detection. So these are some of the application areas. There are many more, This is not a very small list has been shown over here. It's not a very comprehensive list, just a token list. And the various architectures, various have been implemented for solving these problems in these areas. For example, RBF, radial basis function, radial basis networks, they have been created for solving the issues related to the process modeling and the control. Multi-layer perceptron, they have been used in a very big way for machine diagnostic applications. Modular neural network, they have been used for target recognition. Supervised learning algorithms, they have been used for portfolio management. One of the very simple NN architecture is called multi-layer perceptron. This multi-layer perceptron, which is a very simple neural network, has been used for creating various medical diagnostic applications. Support vector machines, they have been used for credit rating applications. BPN, back propagation neural network, that is one of the very robust neural network, one of the very so BPNs, they have been used for targeted marketing. Multi-layer perceptron, deep neural networks, convolution CNNs, convolution neural networks, they are being used for voice recognitions. In fact, deep learning, a lot of work is happening in the deep learning. So CNNs are used therein. So for voice recognition and for various other types of the problems, they are being used. Financial forecasting, right? People have implemented back propagation algorithm for that purpose. Deep neural networks, they have been used for intelligent search and for fraud detection, gradient descent learning algorithm or an LMS algorithms, they have been used. Dear friends, I hope that you might have already have some exposure neural networks. So one of the very key element which is there in the artificial neural network is the kind of the activation function which is being used. So the some of the activation functions, right, for some of the algorithms in this completable, these activation functions have been written on the most right hand side. So right, so for various applications, the algorithm which were being used and the activation function which was used for intelligent search, deep neural networks were being used, and the activation function which was used is logistic function. So, right, going through the fundamentals of artificial neural network, which is very simple, because still we don't understand how it actually works, we cannot deploy it for some problem. So here in this particular slide, as you can see, a very simple neuron is being shown. Right? It is similar to the neuron which is there inside our human brain. We are calling it artificial neuron. So an artificial neural network is the collection of such neurons, and these neurons, they are sequenced, they are being put into series, and also they are into parallel. There is a concept what we call as layers in artificial neural network. So there are multi-layers, in input layer, output layer, and intermediate layers, or also called a hidden layers. In these various layers, various neurons remain. Right on the most extreme side, what we call as input layer, there are neurons which accept the inputs coming from the application, from the problem which has to be solved. So here, as you can see in this particular figure, x1, x2, x3, and all these xn, these are the various inputs which are being given to the neuron. A neuron can accept multiple inputs like this, and there are many neurons also in a neural network. So the number of inputs can be extremely large. The neuron generates an output. There can be multiple neurons in the output layer. So therefore, the number of outputs can also be extremely large. It is driven by the application. So mostly, these ANNs, they are being used for the problems which lie into the category what we call as MIMO, multi-input and multi-output, problems. So so there are various inputs which are being created. So x1, x2, x3, x4, so on and so forth, the inputs which are coming to a neuron, these inputs are being multiplied. These x1, x2, x3, x4, they are the values which have been encoded, right? They have been put into the binary form, x1, x2, x3, x4, And then these inputs, they are being multiplied by the weights W1, W2, W3, W4, so on and so forth, Wn. So these are the weights by which we multiply the inputs, right? So depending upon the values of the weights, an input can be given more importance, the other input can be given a lesser weightage, lesser importance. So like this W1, W2, W3, the selection of these weights, that happens automatically, but for the first time, a random weight has to be given, right? And once they have been put into training, so these weights will be updated automatically by using various learning algorithms, weight updation algorithms that happens. But for the first time, some suitable value of the weights have to be assigned to the various inputs. And these weights are called connection weights or synaptic weights. And these connections, precisely, they are called synapses. And lastly, what we see that there is one more input that is written as B, that is called bias. And the purpose of the bias is to create some tangible output even if all the inputs are zero. So that is the purpose of the bias. So bias input is also given. This is an input which is not from the application, but that is by the design, because we wish to create some tangible output, right? Even to show that there is no input. So for that, bias has to be created. And this bias input is always given the weightage 1. So this way, so the bias input and right has to be given to the neuron with the weightage 1. So all these inputs, they get duly multiplied by their weights, and then right, what is shown in the summer here, you can see in this particular slide inside, right, in this oval, half of the portion of the oval has been shown as a summer, and half of the remaining, right, the right one is sold as the threshold. So the summation happens, right? The weighted summation happens W1x1, W2x2, W3x3, so on and so forth. It happens for all the inputs. And lastly, the bias is also added to it, plus B, because B multiplied with 1 is B. So that way, right, what is shown here, summation xi wi from 1 to n plus B, that is what is done by the summer, and then it is being passed through its threshold unit. Threshold, depending upon its value, right, what are the limiting values, it creates the output 0, 1, or if it right, it can also create a bipolar output. Bipolar output means instead of creating 0, the output would be -1. So the threshold unit which is being used suitably, the purpose is to create, right, either a binary output 0 or 1, or a bipolar output -1 or 1. So that is right, how we actually create an artificial neuron. And this way, that is how a neuron is created, and the neurons, such neurons are being put into artificial neural network. We create artificial neural network, right, for various purposes. The applications, the applications already I had shared in the previous slide. So what I had mentioned in my previous in my this discussion about ANN, that the inspiration of ANN has been taken from BNN's biological neural network, right? We engineers, we studied that how a biological neuron works, mimic, right, the biological neuron to create an artificial neuron, and thereby to create a biological neural network. So something like, what we call the inputs, what we had been calling, they are called dendrites, precisely, right? In the biological, actually a small cell having threshold, right, and summation happening inside. Naturally, that is all the God has created. That is being communicated, that is being sent through a tissue, a set of the fibers called axon. Dear friends, we have also used right for various applications, right, one more architecture apart from fuzzy logic or artificial neural network. We have used GA. In fact, GA has been left back now. We have so many other optimization algorithms, right, P&O and Colony, many others I have seen, right, in the past few decades. The MTech students and the PhD, right, the PhD, they are using various optimization algorithms, and many have come up. GAs was one of the very initial algorithm which was being used for optimization purpose. Believe me, friends, that these various algorithms which have come up today, right, somewhere they reflect partly the spirit of GAs. So genetic algorithm, right, which we started almost 3 decades before, right, in this country for right various applications. That was a huge technique, right? Concept of natural evolution was used in GAs. So this concept of natural evolution was reflected in the various logical steps of the genetic algorithm. The algorithm was reflecting the process of natural selection, where the fittest individuals are selected for reproduction in order to produce offspring of the next generation. Dear friends, in fact, GA, right, as I mentioned, GA was used for optimization purpose to find out the locally maximum or locally minimum solutions to the various problems, right? For global maxima and global minima, we had the conventional methods which had been working very well, but somewhere there was a need for local maxima and local minima also. So GAs had helped in that purpose, had helped for that purpose, right? In fact, many of the applications have been developed. GA, one of the right project which we did was for robotic arm. So right, optimally operating the robotic arm. So it was GA controlled, right? The processor which we had put there, the controller which was being used in that, the program which we had burnt was based on genetic algorithm for optimal displacement, for optimal movement of the robotic arm. Since robotic arm is in industry, it is mechanical arm, so it consumes energy, right? Because it has to overcome its inertia, right? And then it has to right, address its own mass. So not only it was requiring the amount of the mechanical energy, but also its control was required. For that purpose, we had used GA. Some of the application areas of genetic algorithms are air flight schedule planning, optimization of mass rapid transit train schedule. One of the very classical problem is what we call as TSP, traveling salesperson problem, traveling salesman problem, is also the problem which was right initially it was solved with the help of genetic algorithms. VRP with time windows, vehicle routing problems with time windows. They are also right since it requires uh, the optimization in its own style. So GA had been used, GA was being used there. So timetable problem. In fact, one of the right over my these 30 years, 31 years of teaching so far, what I have seen that creating the timetable is always a very onerous task. The timetable coordinator, right? For him or her, it really becomes a mind-boggling issue to fix everything, right? At the same meet all the constraints, meet all the right. At the same time, we have certain priorities, right? So creating a timetable is also an optimization problem. And in the past, the publications have been reported in extremely good journals, and the transactions were had for the GA. Designing a non-conflicting class timetable for a university or for any polytechnic or some other organization. GAs, they have genetic algorithms have also been used for multiple criteria production scheduling. Production which happens in the industries, right? For that purpose, also GAs they have been used with minimum wastage, maximum utilization of the production line, with minimum energy consumption, etc., etc. Being right, they come as a condition in the GA logic. Floor layout, antenna design by communication engineers. For that purpose, also genetic algorithms have been used. In bioinformatics, that is one of the right, very exciting area to work upon for multiple sequence alignments, right? So the algorithms has been used. Of course, when we say genetic means, it sounds like, right? Of course, it is a biological term, but here in the engineering context, in the engineering perspective, right? Because genetic creates the solutions which are derivatives of the previous solutions. So in the same way, we also, right, deploy GA to create more and more better and better solution from the previous solutions, from non-optimal solution to the optimal solutions. That is how the whole journey, right, takes place when we implement GA for a problem to find the optimal solutions. The fundamentals of the genetic, if we look at the right various steps which are involved in GAs, for which we need to write a suitable code. So after the start, it is the initialization, that is the right, that is the resetting. And after the right initialization, we need to create what we call as initial population. Initial population, right, means the initial solutions to the problem, right? And these solutions might be purely non-optimal, right? So the initial population is actually required because they have to get into further, right? Further, they have to do certain things. So initial population, minimum 2 solutions are required to start a GA, and then selection is been done, right? Of course, if we have 2 solutions, the selection is forced because we need to have at least 2 solutions. But if there are more number of right solutions, what we call as initial population, in that we have to see which of the population, which of the solution is best. So we have to create, some kind of rank 1, 2, 3, 4, 5 like that, and the best 2 have to be used for further steps in the genetic algorithms. So from the initial population, what we call as, there comes a process of creating the new population. Of course, right, there is a decision block, yes and no. So there is a right, what we call as a crossover. Crossover is one of the step, one of the process, sub process which is being done in GAs. And in the crossover, right, we use the previous 2 solutions to create new solutions, to create new data values. And after the crossover, still if we find that those new data values, the new solutions are not in the right direction, so at times we may have to do mutation. Of course, mutation, right? In fact, crossover and mutation both are defined by their probability, what we call as crossover probability and mutation probability. For a good genetic algorithm, right, application, crossover probability should be as large as possible, and the mutation probability should be as small as possible. Crossover probability is a well-designed process, but mutation probability, the mutation is a random process, so that is why mutation probability is kept as small as possible. Crossover probability should be kept as high as possible to create a more diverse, right, sequence of the solutions, right, which are better than the previous ones. So crossover probability should be kept very, very high. And after that, if after the crossover and the mutation, right, there, that is the last one. And if we find that the new solutions which have been created after the mutation, they are the good ones, so we can stop over there. But if we find that their fitness is not right in the range which we have designed, which we are looking for, so those data values, those solutions which are non-optimal or suboptimal need to be further refined, right? Again, going through the same crossover, mutation, etc. So these are the steps which are the part of, which are the integrated part, right? Integral part of the genetic algorithms. They are to be repeated. Dear friends, in this right, I had been right. I had thought of that I shall be talking about the applications for sustainable developments based on fuzzy logic, based on neural networks, based on genetics, and also things. Internet of Things is one of the right industry 4.0 right option. It was one of the industry 4.0 proposition which came, right, which got a lot of it was right, it was discussed, right, and many applications were being created which were IoT based. So Internet of Things, right, we all know in our own styles. So Internet of Things actually involves two entities. One is what we call as internet. Internet is used for data or signal communication, right, over the entire globe, right. And the things means sensors, the devices, right, engineering devices, sensors, actuators, motors, etc. It depends upon the application. So the engineering entities, they become the things, and internet is used for data transfer, signal transfer. So then together it becomes Internet of Things. In this particular slide, what I am showing with you is right, there is a talking refrigerator. You can see this graphics. This is a very interesting graphics. This is one of the IoT application, right, which we also developed here in my own organization as a project. So this is a talking refrigerator. So this is a smart refrigerator. So in this refrigerator, for example, right, I'm just for the sake of the discussion, I'm mentioning it. Say that we store certain amount of the milk in milk bottles. So say that at least 4 liters of milk, one liter bottle is there. There are 4 1 liter bottles which are containing the milk. Now there is a sensor. There is a sensor that keeps on counting that right, how many bottles are left inside the refrigerator. Since it is a smart refrigerator working on the concept of Internet of Things, so therefore this smart refrigerator, right, it will keep on counting the number of milk bottles which are left in the refrigerator. Suppose, right, we as a designer, we as a user, right, we have to define a threshold. Suppose whenever the number of bottles becomes lesser than than two, right, four is the maximum right number of bottles, or it can be even more. There is a threshold that needs to be defined. Say minimum number of 2 bottles are they should be there all the time. So whenever the number of milk bottles happens to be 2, right, then this smart refrigerator will send, right, a message, will send some kind of message similar to the WhatsApp or right through internet, assuming that the person right is having is having a smartphone with internet data right in there. So this message will pop up on the application which has been developed. So an app has to be created which will be integrated to this refrigerator as a device on one end. So on that app, it will appear that the milk bottles left are 2. So after this message, right? After this message, the person who is there, of course, right, wherever he is sitting, right, well, say in the office, will come to know that only 2 bottles are left. The remaining 2 bottles are more bottles have been consumed. So that person, while coming back from the office or from some other place, right, in the evening, will bring the required number of bottles and will once again fill the number of bottles back into the refrigerator. Will put back into the refrigerator. The moment the number of bottles happens to be more than 2, right, 3, 4, or whatever, because minimum has been defined as 2. So again, in the app, which is there, right, on the smartphone of the person, the message comes that the requisite number of bottles are available in the refrigerator. So this becomes a closed loop application wherein the device which has been made smart by using right IoT devices, I shall be talking about that, gives a signal, right? The signal can be any signal over the phone, right, through the internet to the user who is the controller or who is the person, right, handling everything, right, to do the required action. And the action in this context was purchasing the bottles because the number of bottles has fallen below the threshold. So like this, right, there can be an inventory control, right, problem which has, right, which can be solved similar to this problem, right, wherein the number of the products, they can be, the count of the products can be kept on the record continuously with the help of real-time sensors. And then the moment the number of products, they happen to fall below the requisite or the threshold, there is some kind of information which is being sent through the internet onto the device of the manager or the controller that you need to replenish the stock, right? In fact, with this growing business of digital marketing and e-commerce, because small warehouses have been created here and there, so inventory control becomes one of the very big challenge, right? At the same time, it is right. You cannot go for overstocking because all the regional areas, all the geographical areas, wherever your consumer is there, wherever warehouse is there, you need to have at least some rate, at least requisite number of volumes, requisite number of items in the stock. So neither understocking should happen nor overstocking should happen, while also taking care of the various issues like weather, transportation, etc. Right, disturbances due to right, so some social unrest, some right political unrest, something like that. So really, it becomes an optimization problem, right? So IoT applications, they have been developed, and this way the devices are being made smart. Internet of Things, it is one of the rapidly growing technology which aims to connect all the devices to the existing internet infrastructure. At the moment, mobiles, computers, tablets, smart televisions, they are being connected with the internet. By using IoT, all the devices, for example, coffee makers, air conditioners, washing machines, ceiling fan, lights, almost anything, right? Having sensors can be connected with the internet. In fact, one of the IoT application on which currently we are working is, right? For example, we all have seen CCTV cameras, closed circuit television cameras, right? Right. I'm just creating one more perspective where IoT application can be created, right? We are working on that problem. So, right, uh, at our house, at our home, we have put a CCTV camera on the main gate. Now, whenever, right, the CCTV camera 24/7, all the time, every time, right, is right taking the picture frames, right, of the person who appears on the main gate, and those picture frames are being sent, right, via the internet on the application, on the app of that CCTV, right, uh, on the smartphone of that person. That person sees the various CCTV camera grabs, whatever are being taken, where one of the grab is also for the main gate. So because one CCTV camera is also on the main gate. So right, this person who might be on some other remote location, right? Say that you have your children or old parents at the home, at the house. Safety and security is one of the major issue, right? That has to be addressed. But you cannot remain in the house or the home all the time because you have to visit your office or you have some field work. So you are away from the home. Now, right, whenever somebody appears, right, on the main gate, the CCTV camera which is installed on the main gate takes a picture grab of the person who has come and sends it right on your application, on the app which is installed in your mobile phone, right, with a small beep or with a small flash message. Then you open that app and you see that who is standing on the right on the picture frame of the camera which is on the main gate. Now, right, you enlarge it, you see it. It has to be a high resolution, right, image picture. Once, right, after you see that, yes, he is a legitimate person, he is your relative, he is not a danger. Then from here, in that app, right, in that application, you also have the options to open the gate or let the gate remain closed. So suppose you click on the option, you select the option, you touch on the option to open the gate. So what will happen? What will happen via the internet, because internet is being used as a communication media here. So via the internet, the signal will travel back to the various actuators which are being installed on the main gate, and thereby those actuators, right, they will, because they have got a command to open it. So there are various right control motors, right, which are there. They will they will come into the operation and they will open the gate. Or if you want, right, if you have touched the option do not open, so there won't be any command which will go to the right motors which have been installed to close the gate, and therefore the gate will not uh, get open. So this is again a closed loop application where right the whole story starts when a person comes, the picture is being taken, the picture is being sent via the internet onto the right application on the phone of the person who is the main owner but not at the home. And then you take a decision as a controller, right, as a master, whether you have to right do this action or to open the gate or not to open the gate. So depending upon the option selected by you, either the motor is right made to operate or is made to remain as it is. Means right, if it operates, the gate will remain closed. So this becomes a closed loop application of IoT for home automation, for home safety and right security. So this is one of the home automation application wherein IoT has been used, right? For IoT, of course, as I had mentioned in the very beginning, that the first and foremost thing what we require is internet, and the second thing is that we require sensors, right, and actuators that depends upon the application. Internet of Things, right? It has been used almost in all the domains today. Then into the right messaging, right, task scheduling, transportation and logistics, engineering applications, industry analysis, right, stock market, recognition, etc. So, this is just a token picture. IoT applications have been developed for the smart refrigerator. Other was about home automation, that is opening the gate or not opening it upon, right, the CCTV grab picture. Internet of Things, to talk very simple about Internet of the Things, it is simply, and it is called IoT. In short, everybody says, right, we all speak it as IoT. So Internet of Things means, we need to have internet and then we need to have things. Things mean the sensors, the data, and then after sensing, collecting the data, right, encoding the data, or just conditioning. After conditioning of the data, the data is being sent, data is then accessible by other things also. IoT is one of the most important technology of current century. We can now we can connect everyday objects like kitchen appliances, cars, thermostats, seamless communication because it's possible between the people. So, right, that is through the internet, between the processes and the things. By means of low-cost computer analytics, while technologies, physical things can share and collect data with minimum human intervention. And in this highly interconnected, interconnected world, the digital systems, right, are being used for recording, monitoring, adjusting each interaction with various things. So by things, right, what do we mean? Right? Possible. So while the idea of IoT which need to be highlighted, which need to be underlined, right? Which have made IoT possible are: number one, access to the low cost, low power sensor technology, affordable, reliable sensors are being right, they are available. As a result, they have made IoT technology possible for various applications, for various sensors which are available, right? So they take they consume the electric milliwatt, right? And also they are very less costly. So not only because sensors are available, so they have really contributed a lot. So because of the very stable internet which is now available across the globe, a good connectivity is a host of network protocols for it, and to the things for efficient, easy data transfer, secure, right? That is the third attribute due to which that has enabled the business and the consumers to access the infrastructure. These cloud computing platforms, right, they are available. Connectivity is there, low cost, low power, concepts are available, technology is available. Of IoT is machine learning and analytics. With the advances in access to the varied and vast amounts of data stored in the cloud, businesses are gathering insights fast and right, is pushing the boundaries of IoT and the data produced by the IoT, right? So this machine learning, which is also being used, has really contributed a lot in developing very conversational, a very simple perspective of AI, that is conversational, means interactive AI. So this conversational AI is also one of the in the IoT application developments for sustainable development goals. Advances in neural networks have brought NLP, natural language processing, to the IoT, right? I hope that we all know about Siri, right? So the assistants, maybe that some of us are also using at our house. So you just say to the device, right? You speak on the device, play me this song or tell me the answer of this question. These devices, right? Because they have to access a huge database, right? Say you ask, right? Tell me, right? Who was the most famous celebrity of 1970, right? Of Bollywood. So this data, right? For this data, the device, right? So Siri or Cortana or Alexa, right? It has to actually go through the huge database, which is on the right other end. So this huge database, which is on the www on the cloud, will be accessed, and then depending upon the question, right, the keywords would be created, and a suitable answer will be put forth by the device, by the Alexa or Cortana or Siri. So these devices, which we call as digital personal assistant, they are IoT applications. They are the IoT-based devices, since they use internet for data accessing, right? And then they use the things. Things means, of course, right? You have spoken on the microphone, and then there is a speaker, and then there are so many signal conditioning. There is a right whole technology inside, fine, which are doing various things, filtering, right, signal conditioning, etc., etc. So the things means the things which are not internet, and then together they create IoT application. So these digital personal assistants, Alexa, Cortana, Siri, which we use for right home purposes, for amusement purposes. So they are based on conversational AI. They are IoT devices, IoT applications. The concept of IoT, right? The concept of IoT is simply to connect the devices with the internet, and then to make to and then to right, to add more and more features in the device. If we look at IoT, Internet of the heart, machines, and few. It depends upon the application for which IoT has to be implemented. A very important thing is that for right IoT application, for IoT device creation, we need to have such a device, we need to have such an object, we need to have such a system which could be right attributed with a suitable IP address, which is digitally accessible. So any object which can be assigned an IP address. And then if we have such many devices, of course, they can be put together to communicate with one another, right? So this way they would be communicating, they would be talking to one another. We call them as talking devices. So these talking devices will be created for that, right? If right, they can be IP addressable. So IP address has to be assigned, has to be created for the device. And those devices which cannot be assigned an IP address cannot be used in IoT. And then they would be doing handshake between them and with the other devices in the network. So this way IoT network will be created. Some of the examples of IoT applications, graduate students and the post-grad students, right? We can create certain models, we can create certain solutions. So some of the IoT examples which are available in the market are autonomous cars or the smart cars. Like, you all might have seen Hector MG, Morris Garage, right? Hector MG car. So Hector MG car, in fact, they write on the label also Internet Inside. So they are using IoT, right, in a very big way. They are using internet, right, for various control, for various data analytics, for various other things in a very big way. Hector MG is doing that. So that is called a smart car because it is unlike the other cars, right, where internet was not used, right, or it was not used, right, on a certain scale. So these cars are called autonomous cars because much like pilot mode in the aeroplanes, right? So these autonomous cars are able to drive by themselves, but they are well supported by internet and the right IoT solutions. Home automation accessory or building automation accessory like Philips smart LED bulbs, Google Home or Amazon Alexa. Already I have spoken about that in the previous slide. Smart televisions, right? Smart televisions, right? In fact, this can also be taken up as a project, right? A small project can be created. So this is smart television intensity control, the size control, the frame size control, right? The song selection, the channel selection can be done. So, right, if it is a smart television, right, what to play, whether to play a YouTube video or to play, right, Netflix or to play some other, right. So, depending upon, right, we can use some kind of sensors. Say they do face recognition, and then depending upon your face, the selection of the suitable stream is being done by smart television, and the intensity control is also being done by the smart television. The selection of the hues, contrast ratio, etc., the things which are related to the hardware of the television, they can also be done. Of course, right, through internet, we are accessing the data which is available on the cloud, on the internet, to be displayed, to be shown on the television. That is the main thing. So smart television applications, there are smart televisions which are already available in the market based on IoT. But we can also, right, if right, we can do the analysis by doing a market survey. If certain features are not available in the smart televisions which are available in the market, they can be taken up as a project work, right, which can be done, right, at various levels academically. MI smart plug is also one example of IoT device. The smart healthcare devices for right in the area of medicine and the health, right, IoT applications are really helping a lot. In fact, we right of late, we had developed an application for which we also got a patent. It was that we had made a smart walking stick. So that smart walking stick was that it was a solution which was developed for developed for the old people. In the day, these old people, right, they go out of the house and they just walk here and there. But since they have become very feeble, right, they have become very rickety, right, they can fall. So right, so this smart walking stick which is being installed with the IoT device, the moment they fall, we assume that the stick has also fallen. So that we had developed. So the signal is being sent right through a messaging system via the internet, right, that to the person kith and kins, or to the right household persons, to which house that old person belongs, that at this particular GPS location the person has fallen. So that way there is a SOS message which is being sent via the internet on the smartphone of the household persons, members of the house, that this oldie who was carrying the stick, he has fallen at this particular location, so you can rush. So this way, depending upon whose numbers we have put in, we have fed into the memory, such kind of messages can also be sent to the doctor or emergency services. So this is one of the application area, healthcare, health monitoring for children also, small children and oldies. They are also the objects which have many problems. So various IoT applications, are being created for them also. So in healthcare, in health monitoring and other medicine related purposes, more ideas are available. We can work on them. Apple is small, so that uses IoT. I had been talking about autonomous car, smart car, internet insight. So just here, without any serious intention, I'm just automotive brand, and already it is available on the roads in the Indian market. Localized hector, it is available in various models with IoT devices installed, on a very high scale inside. When we talk about Internet of Things, why we are going for it. In fact, in Industry 5.0 also, IoT advancements, they have been given a lot of prominence in Industry 5.0 now. In 4.0 is one of the main theme area on which many manufacturers and a lot of commercial activities are happening. IoT, it has got many advantages. The first advantage is the data. The more the information, the easier it is to make the right decision. Knowing what to get from the grocery, for example, while you are out, without having to check on your own, So such kind of things where we need data, where we require information. So it becomes very easy talking about the data or the information, because through internet and the IoT device, it is very, very easy to handle. So this is one of the advantages: data handling, data access, information handling, information access. Second advantage, which was for IoT, which IoT devices had, it was tracking, Already in one of my example, I have told you that, is making the smart walking stick where GPS location comes. So this way, if we have internet, if we have autonomous car, even if somebody steals that, they will be tracking where, on what geographical coordinates the vehicle has been taken. So that way, we can easily tracking in one context. Similarly, tracking can also be done, for various other things in other perspectives. The tracking is one of the main advantages of IoT applications, which are used in IoT devices. Not only they keep a track on the quality, of the things, date of the product, about smart refrigerator in the initial few slides. So it was not talking only about the quality and the quantity, but also we can extend the information analysis, the data analysis for even seeing what is the expiration date of the bottles, milk bottles, or what is the expiration date of the medicine that has been stored in the refrigerator, or a product, because the product which can be ingested, they come along with the expiry date. So in such cases, can be done, and it is only possible with the help of the sensors and using the internet, right? So tracking is one of the advantage attribute of IoT applications. So knowing the expiration date of the products before one consumes, right, which will be unsafe and will lead to, right, some dangers of the life. So they will be addressed if we have IoT enabled devices. Also, right, we will never run out of anything when you need it at the last moment. I was talking about, maintaining minimum number of bottles in the refrigerator. So the thresholds can be, right, created depending upon our requirement, our consumption levels, and then IoT does everything, right? Not only from the right action angle, but also from the control angle and from the right data storage, data analysis. All right perspectives are being well handled by IoT devices. The third advantage is about time, the amount of the time which is being saved in monitoring, and the number of right otherwise the widgets or the trips which may be done physical, right, IoT applications, IoT deployment. The time is being saved in the monitoring, data analysis, right, physical widgets, etc. Aspect is one of the biggest advantage of IoT applications. Right? On a non-viable solution, right? But if we really find that IoT enabled, right, devices, IoT created solutions, they are best, right? They are best financially viable. And instead of right putting the human beings for monitoring and maintenance purposes, the IoT devices, the IoT applications depend how we have created it on partial or complete maintenance feature inbuilt. Nothing comes with the other side, right? This is the world of duality. If we have plus, we have minus. If we have day, there is night. So Internet of Things, right? Not only it has advantages, but it has got some very serious disadvantages. In fact, this is one of the right research area which needs to be looked upon. So these disadvantages, they are the scope of the work which can be right taken up as a challenge, and we engineering fraternity to right create new solutions for overcoming these disadvantages which are available in the present IoT devices, IoT deployment. One is what we call as community disadvantage. So as of now, there is no standard for tagging and monitoring the whole of sensors, starting from electrical sensors, mechanical sensors, electronic sensors, and then so there is a need for standardization, right, in the sensor technology. The manufacturers, they need to really sit down and right need to right in other domains also of engineering, right, interoperability, right, flexibility, all these things are being addressed in extending the IoT applications, expanding the IoT applications. A uniform concept like USB or Bluetooth, right? Such things are required, and it will not be difficult. So when we have the uniform concepts, like it is acceptable, it is acceptable, it is right addressable, it is right. It can be integrated, right? Then the compatibility issue is being addressed. So there are several opportunities for failure systems. For example, right, uh, for example, here I have mentioned both you and your spouse may receive messages that bifurcations and by suitable isolations of the right channels. Such kind of issues are being can be addressed, but we really need to upon the right is being avoided. So complexity is available in IT applications. This is one of the disadvantages, right, which can be addressed in the future developments. Of course, we all face this problem very common of today's times. Right, privacy and the security. Privacy is a very big issue, especially with the IoT applications. All the data, right, whatever is being put onto the right onto the internet, it should be encrypted. Right, it might not be possible to encrypt all the data, but it would be good, because if data is not encrypted, and then again it depends upon the encryption levels, right, what encryption algorithm has been implemented, because the hackers are too smart, right, they can sneak into your data, they can decrypt, or they can just cut open your right data engine and can see through what is there. All the data must be encrypted, so that data about especially with the financial data, the data related to the defense, the data related to the nuclear installations, the data related to the power plants, the data related to the medicine, right. uh, so these are very crucial, right, nature. These are very crucial data. Their nature, the data nature is too important. So the data needs to be encrypted in all such cases, and then it makes the whole data transfer very, very heavy and bulky. And then, right, when we deploy encryption algorithms, the handshaking between the devices also becomes a challenge. So all the data must be encrypted, so the data about financial status or how much milk you consume isn't common knowledge at the workplace or with your friends. So privacy and security is one of the issue, because we are using internet. So whatever are the issues of privacy and security with the internet, they do exist with the IoT applications, IoT devices. One of the disadvantages of IoT is the safety, right? That is the safety of the right. The software can get hacked, the personal information can be misused. There are enormous possibilities; they are endless. So the right, for example, if you are using right, say we are sending the medical data, the data of a patient through the internet. So the if data is being hacked, right, so data might be changed, or the prescription which is being sent forth by the doctor sitting from, say, doctor is sitting at America and sends the prescription to somebody at Delhi. So if the data is being hacked, the prescription can be changed, or the accounts, the payment account details can also be hacked. So safety is there, issue is there. Privacy, security, safety, all these issues are there with the Internet of Things. So this is one of the upcoming area where my friends from computer science, right, they can really handle these issues: privacy, security, safety. We do have limitations being electrical engineer, right? But the people from computer science and especially information technology, they can probably come up with right, with tangible and robust solutions for addressing these disadvantages of current IoT applications, current IoT devices. Right. This is a very interesting information about IoT, right? If we look into the IoT, how the inspiration for IoT devices came up for sustainable development, for creating sustainable solutions. So if we look back, way back in 1982, right, the concept of smart devices came up, right? And there was a Coca-Cola vending machine at Carnegie Mellon University that is said to be first internet application. So this Coca-Cola vending machine was IoT device, internet-enabled device, and it was able to report the inventory, whether new loaded drinks are cold or not. So temperature sensing was being done, and depending upon right temperature which was sensed about the right beverages and the right those bottles, right. So it was that temperature data was sent to a central control system, a central control station, and then so it was being sent through the internet. But this internet was highly localized. It was not what we see today, right? www. Between 1993 and 1997, lot many companies they proposed solutions like Microsoft and the Novel's Nest or Novel's Nest. IoT, the Internet of Things, right? This concept was given by Kevin Ashton of Procter and Gamble. Later, it was adopted by MIT's Auto ID Center. Right? It is all about the history of it. And right at that point, when in 1999 we had been talking about IoT applications. So exactly it was not Internet for Things, right? Because Internet was too limited. So initially it was involving a lot of RFID, what we call the people from electronic and electrical, they can understand that. RFID, right? That is radio frequency identification was being done. And that was the part of the IoT deployment. But today, right, RFID has taken a back seat. In fact, we have much better, strong, right, support systems for communication, data transfer, and information communication. Hardware and the software which are required for IoT deployments, right? Whenever we wish to create an application, right, based on the IoT, of course, we require certain hardware, we require certain software. So on the hardware side, what we require sensors and the devices. They will depend upon the application, which will be an integral part of the IoT deployment. Communication, right? Of course, since we are using internet here, so right, we know that different kinds of networks are available for communication among the devices and with the platforms. So the various communication modules, which are again available as the hardware, right, which create the communication with the cloud platform or the third-party systems are to be built, are to be integrated. The cloud platforms, right, and then we require certain application platforms like Arduino, in fact, right, I have seen many of our students, right, at their BTech level and also some at the PG level, they come up with some very ingenious engineering applications where they use, these application platforms, Arduino, or Raspberry Pi or BeagleBoard or Intel's Galileo. Also, Edison boards are available. Qualcomm, right? Qualcomm has manufactured an array of enterprise-level IoT technologies, especially for cars and cameras, and in the healthcare. So these platforms they enable, right? They support IoT. IoT hardware components, right? They vary from low power. This power is the power that is it's not computational power, but this is the power which is being consumed. And single board processors like Arduino, which are basically smaller boards, which are plugged into the main boards to improve and increase the overall functionality and to bring out certain specific functions like, heat sensing, light sensing, or GPS location identification or interactive display, right? A programmer specifies a board's inputs and outputs and then creates a circuit designed to illustrate the interaction of these various inputs and outputs. The inputs and outputs, they are to be clearly identified. They are to be clearly right, brought out by the designer. Of course, they will be application driven. Another, apart from the Arduino, which is used as a IoT platform, another very common platform which I have seen as of now is Raspberry Pi. Raspberry Pi 2. It's a very affordable, tiny computer, right, which can incorporate the entire web server, right? In short, we call it a Raspi. It has got tremendous processing power, right? And then it has got good memory also. It can run on Windows 10, right? On it as well as IoT Core. Raspi, right? For that, for Raspi, right? For Raspi programming, we use Python as a language. Dear friends, here I am sharing the pics of these IoT platforms which are used for creating the various applications. So this is a hardware IoT platform. So that supports IoT application. This is the Raspberry Pi, Raspi, BeagleBoard, the third one. We have multiple options, right? So energy consumption, computational ability, right, and memory, all those requirements we have to look into as a specification while selecting a suitable IoT platform. This is a BeagleBoard. It's a single board computer with a Linux-based operating system that uses an ARM processor, and it is more processing ability than the Raspberry ARM Advanced RISC machine. It's a We all know that it's a family of reduced instruction sets, computing architecture for computer processors which are configured for various environments. IoT hardware building blocks. So dear friends, whenever we are thinking of creating an application, IoT application for it should be sustainable, right? In the very beginning of this task, I had shared with you lot many issues which are related to our life, right? Which are related to our civilization, which are related to the planet, which are related to our ecosystem. So all the issues, right, in our own style, people are contributing, right? And in the future also people will contribute. At present also a lot of researchers are working day and night, right? Industry is also working day and night. We are also hammering out day and night, right? On the various we have right, most of us are working on some on the research projects related to somewhat related to such technologies in these areas. IoT hardware building blocks. When we talk about IoT hardware building blocks, right, we require sensors as the thing, data acquisition module, which will convert the physical signal into the digital signal. And then the third module, what we require is data processing module. The computer is used as a data processing module, which will process the data, do the data analysis, store the data, and right, other will do other edge computing things, right? Edge computing will be done. And then communication modules, right? The fourth and the last thing which is required in the IoT hardware. So the first thing is right, sensor, that is called thing, data acquisition module, data processing module, and communication module. So once the data has been analyzed, processed, control action has been generated, it has to be sent. So it is being right, it can be communicated with the third party system, right? Or it can be put onto the cloud, sent in the cloud. So communication modules are to be used. That is the fourth hardware module. IoT sensors, right? The very first thing in IoT, Internet of Things. Things means sensors, right? The I had shown you this block. Thing, the asset you want to control or monitor. So that will require sensors. So the most important of IoT hardware is the sensor. And these sensors, right? There are variety of the modules which are available, like energy sensor, energy module, radio frequency module, power management module, right, etc., etc. So in this particular right slide, I'm just sharing right the various application areas, right, wherein IoT sensors are available, and where they are not. Right, it's not a very comprehensive picture, right? Might be many of the IoT sensors of other domains they are missing in this picture. Some of the right IoT sensors in some of the application areas which are available and they are being used in the IoT devices are for position, presence, proximity monitoring, motion, velocity displacement monitoring, temperature control, humidity data acquisition, analysis, control, acoustic sound vibration, chemical analysis, right? Gas right? Spectrometry, flow control, force, load, torque, mechanical side, leaks levels, electricity and magnetism, acceleration, tilt control, etc., machine vision, optical, ambient light. So we have sensors, we have plethora of sensors, right? And wherever we don't have sensors, we can go for indirect measurements, right? So sensors, wherever we have sensors available, we can have direct measurement, but where we don't have sensors, we can have indirect measurement, right? For example, with the help of two sensors, you can create the right, create the data for which sensor direct sensor is not available. So this way we create indirect sensors, and indirect sensors are created in the program itself, right? You just write a small line in the program for multiplication, division, or whatever. So that will create a virtual sensor. So that way, wherever we don't have physical sensors available, right, virtual sensors are being created as the program line. IoT, right? IoT hardware devices, right? In wearable electronic devices, IoT has created a lot of penetration. What we call as right wearable electronic devices, or this area is called haptics. So haptics is the area where IoT penetration has really gone to a very right deep level. So wearable electronic devices, like right, they can be worn on the head because you have to wear it. So they can be worn on the head, or they can be put around the neck, or put around the arms or torso or the feet. Right. For example, on the extreme left hand side, it's a smart watch, right? And then it's a smart goggle, right? So that's a small right wristband that is going to right, that is going to show right the calories burned, like that. So around the head, right, for the head, helmets, IoT hardware devices, right? IoT hardware. The IoT devices which have been developed are the smart helmets, smart glasses. Jewelry collars are used for necks, wristwatches, wristbands, rings. Clothing pieces, backpacks, shoes, socks, etc. for feet. Right. So they have been developed. Day-to-day devices that we use, desktop, cell phones, and tablets, they are the integral part of the whole IoT application. Largely, right? Not in all the cases, but in most of the cases. The desktop computers are simply used for, right, which provide the user with a very high level of control over the system, right? The various settings of the application, settings of the system. Tablets are used as a remote access device, access to the key features of the whole IoT system. Cell phones, right, for remote functionality, and certain other reconfiguration settings, essential settings, the setting modification. Software of IoT, because embedded systems have less storage and processing power, their languages are different. So the most commonly used OS for embedded systems are Linux or Unix like OS. OS is like Ubuntu Core or Android. IoT software encompasses a wide range of software and programming languages, right? Starting from C++, Java, Python, to the embedded specific choices like Go or Parasail from Google. Go is from Google. So that's I'm just leaving that. Whatever would be the relevant that I shall be talking upon. Right. In because this is one of the very basic concepts. Hello. Hello. Hello.
Yes, sir. Yes, sir. Yes, sir.
Okay. So, right, because, from the very beginning, I was talking about closed loop. Right? So even though we can go for an IoT application which is open loop, means just halfway through, but it would be better if it is a complete loop, right? Because the control action should also be communicated via the internet. Then only the complete solution would be created. So, but it can be open loop also. So the solutions which are being developed, the IoT solutions which are being developed, they broadly fall into two categories: open loop and closed loop. Right. This I shall be leaving. Right. I shall be just leaving that. I had in the very beginning I had talked about, right, ANNs. I won't be going into that because this itself is a very bigger area, and we have more than 40 plus architectures of artificial neural network, right, which are being used for various purposes. I'm just leaving this for the moment, right. Mm. Just one minute. Okay, let me just go back, right? All right. Okay, so neural network, right? Okay, just leaving that. Already this I had explained you, right? So some of the basic elements of ANN. Once again, I am revisiting ANN. So they are the weight factor, threshold, activation functions. In the activation functions, we have the choices, like we can go for a linear function. It depends upon in what scale we wish the output to be created by the ANN, or it can be a piecewise linear function, or tangent hyperbolic function, or threshold function, or sigmoidal function. Okay, this already I had discussed, right? The various inputs are being multiplied with the weights and then subtracted, right, from the threshold values to create the net output. And the net output is then given to the various activation functions. For example, here in this slide, what I'm sharing is the binary threshold function. It generates a binary output, either 1 or 0, right? Or we can use a bipolar threshold function I had mentioned in the very beginning. So what we had 0 there, it is -1 here. So in the case of bipolar thresholding function being used in the ANN, the output will either be +1 or -1. Active piecewise linear function, right here, you would be having the values between -1, including the -1 and 1, and the values in between. So that will be created by piecewise linear function. A sigmoidal function is also used. This is also one of the very interesting activation function which is used for nonlinear data mapping, nonlinear data map to be created between the output and the input. So wherever we expect a nonlinear behavior from the ANN, so one of the simplest choice is that use a nonlinear activation function, and one of the option can be that sigmoidal functions can be used for that purpose. Neural networks, they have multiple structures. I won't be talking about that. Forward and recurrent, right? Okay, I'm just leaving that. Hello. Okay, leaving that. Of course, learning method is one of the, right. It's a very important aspect of the whole neural network training purpose, training exercise. So suitable learning algorithm is being picked, right? It can be supervised, reinforced, or unsupervised. Multiple choices are there. Unsupervised is heavy and competitive. It's whole a subject area in itself. Anyway, application learning has to be imparted. And then applications of neural networks, probably I had already said. So just have a quick review of the application areas of neural networks: speech, character recognition, signature verification, human face recognition, stock exchange prediction, image compression, NER, named entity recognition, semantic parsing, question answering, paraphrase detection, etc. Future applications are there. Okay. So I just stop here with the last right motivational slide by Sadhguru. What he says, stay motivated. Frustration, discouragement, and depression mean you are working against yourself. Okay, thank you very much. Right. In fact, I had tried to cover 3 or 4 technologies, architectures in my lecture, right? And some of the applications I have shared with you, right? So this is all about myself. Dr. Arnab, I think we can invite the questions if
Yes,
they are
sir.
there.
Yes, sir. Yes, sir. So I'm requesting all the esteemed participants, do you have any queries? Please let us know. Participant, please mute yourself if you
Hello.
don't have. Hello.
Hello.
Yes.
Sir, I have one question.
Yeah,
In
please,
that
please ask.
refrigerator application, that IoT inbuilt refrigerator
Yes,
application, that
yes, yes. Smart
uh,
refrigerator. Yeah.
yeah. So what actually my question is that, suppose you talked about the milk bottle.
Yeah.
So if by any misuse if happens, suppose for an example, anyone accidentally keeps water bottle of same size instead of milk bottle.
Go
So
ahead.
will the system will be able to distinguish that whether it is a water
Yeah,
bottle,
definitely.
or it will count like
Yeah.
that it is a milk bottle has been added?
Yeah. In fact, I talked very simple. I was just talking about counting the number of milk bottles. We can further extend it, right? So wherein you can have the colors and also some kind of chemical analysis sensor, right, can also be done. So we have to use suitable sensors for that purpose, and they will also create the data that has to be sent, right. They will first ensure that it is the milk or it is not the milk. So it's very easy, since we use right, we do processing locally, right. Every smart application, every IoT application, every embedded application comes along with a controller, microprocessor, controller, microcontroller, right. In the controller we have right, data processing happening. So right, in my narration I just told about counting the number of bottles, but now you are extending the discussion, right. Of course it has to be done that way, right, because there is a need for that, right. Instead of milk bottle, somebody puts some other bottle. So for that, there can be right, if it is a standard milk bottle, so it will come with a label. So the whole image can be grabbed and image processing can be done to read what is the data, right, Doctor? So that way it will ensure
Yes, sir.
that
Yes.
it is the right product. So that will become, it's not difficult. If the way we can count the number of bottles, in a similar way we can also do the image processing and read the barcode or the right, another code which can be scanned to see the expiry date, to read what is the product name, right, who is the manufacturer, like that. So it can right, it can be built as a standard data inside the right, as the few program lines where it will be compared. And if it is some fraudulent, right, if somebody tries to play a mischief, instead of putting a milk bottle, somebody puts some other bottle, it will be detected. And then that can also go as a warning, right, right, or it can flash on the app, on the smartphone of the main user, main right, owner of the house. So it can be easily done.
Okay, thank you, sir.
Thank you very much.
Any other queries from any of our participant? Okay, I think there is no other queries, sir. So thank you, sir, for your session. Okay, sir.
Thank you,
So
Dr.
from
Arnab.
here we can able to understand lot of ideas related to the IoT and the basics of that different machine learning. I mean, different uh, artificial intelligence basics, languages, all those things. Okay. So thank you, sir. Now we are concluding the sessions right now here, sir. Thank you, sir.
Thank you, Dr. Arnab. Thank you very much.